This video will explain about light-emitting diode. Light-emitting diode is a semiconductor diode that gives out light when a forward voltage is applied to the device. The diode is formed by bringing two slightly different materials together to form a p-n-junction. In p-n-junction, the majority carrier in the p-type is known as hole, while in n-type, the majority carrier is an electron. For better understanding, let's take a look at the energy band diagram of p-n-junction in forward bias. In forward bias, there is a presence of external voltage being applied to the p-n-junction. We called it as forward voltage. In forward bias, the electric field is lower than the equilibrium value, which means the amount of electric field in forward bias is lower than the amount of electric field in zero bias p-n-junction. Because of this, the size of depletion region in forward bias is smaller than zero bias, as you can see in the energy band diagram. From this energy band diagram, we can see that the majority carriers in the n-type are electrons and the majority carrier on the p-type are holes. The diffusion of carriers will occur from high concentrations to low concentrations, which means the electrons from conduction band in n-type will go to the electrons in p-type conduction band, while holes in p-type valence band will diffuse to n-type valence band. And when the electrons from conduction band combine with hole in valence band, this process is called as recombination. There are three types of recombination process, which is radiative, non-radiative, and Auger recombination. In Auger recombination, there will be at least two free electrons at the conduction band, and the first electron is having an extra energy. When the first free electron in conduction band is recombined with a free hole in valence band, it will gives out energy in terms of phonon, which is heat, to the next free electron on the conduction band. The free electron that received the free energy will excite to a higher level, and it will only go down back to the conduction band when it no longer have an energy. Next, let's take a look at non-radiative recombination. If you notice from the diagram below, you can see that there is a straight red line appear in between the conduction and valence band. Well, this line is known as trap energy level, and it exists due to present of defect in the semiconductor material. The line can exist anywhere in between the conduction and valence band, but now, to make it simple, let's assume the line is in the middle. When the free electron in the conduction wants to recombine with free hole in the valence band, it will first stop at the trap energy level, and then it will release phonon as an energy, which is heat. Then the free electron will continue its journey and go to the valence band to recombine with the free hole, and it will once again release an energy in terms of phonon. In LED, non-radiative, and Auger recombination is not what we want, because it gives out energy in terms of heat, not light. Now let's take a look at the third type of recombination, which is radiative recombination. In radiative recombination, free electron in conduction band will directly recombine with free hole in valence band, and it will release photon, which is light, as an energy. Now this is the recombination that we want in order to make a light-emitting diode gives out light, not heat. Through recombination theory we discussed, we can see that even with just a tiny electron and hole, different energy can be produced according to certain situation. From this we can see and acknowledge the power of Allah the Almighty. Something that was initially very small and cannot afford to be seen with the naked eye is able to produce an output that is very important and capable of helping us to have a comfortable life in this world. Now, ladies and gentlemen, you might wonder, how can an LED emits light with different color? Well, the answer is bandgap. The color of light being emitted by each LED depends on the wavelength of the semiconductor material, which actually depends on the bandgap energy of the p-n-junction. There are two types of bandgap, which is direct bandgap and indirect bandgap. In direct bandgap, the minimum of conduction band is in line with the maximum of valence band. The energy that will come out is photon. However, in indirect bandgap, the minimum of conduction band is not in line with the maximum of valence band, and because of this there is difference of momentum, and hence, the energy that come out is in terms of phonon. Allah has created everything in a perfect shape and form, and it's up to us as a Khalifa in this world to keep study and learn the wonders of the world. As we can see previously, even though from certain recombination and bandgap we cannot get light as an output, but we still can get something different out of it, and it's up to us as a Khalifa to make a good use of everything that Allah has given. To know more about LED, you can proceed to the next video that will discuss in details about the advantages of LED as well as the technology advancement of LED.
Created using Powtoon.